In this part we will start with the applications of electrochemical series. So what are the different applications? First one is to construct a galvanic cell. We have seen this in the last part, but we will see it again. Next is the important part, feasibility of a redox reaction. So using electrochemical series you can see whether the two species, if mixed, whether the redox reaction will take place spontaneously or not. The others are determining pH of a solution, solubility product KSP, equilibrium constant, its role in thermodynamics and relationship with thermodynamics and potentiometric titration. All these applications will not be dealt here, but few will be dealt in details. So first, construction of a galvanic cell, which we have already seen. Here I am picking two half cells and I am trying to connect them and to see what type of cell will be formed. So here one is copper and other one is silver electrode. So among these, silver is having higher electrode potential, so silver will act as cathode and copper will act as anode because of its high electrode potential value, E0 value. Silver will be the cathode and copper will be anode. So if you represent using notation, you can represent it like this: anode first was copper and there it's the oxidation reaction, so Cu gives Cu2 plus, then salt bridge, then cathode with its reduction equation, that is Ag plus giving Ag. So we now know that Ag is the cathode. So what is E0 cell? E0 cell is equal to cathode minus anode electrode potential. So 0.8 minus 0.34 and the potential of electrode or the cell is 0.46 volt. So this is one of the application of the electrochemical series. In the electrochemical series, there are two species which can be said as most stable species of the electrochemical series. One in the oxidized part and the other one in the reduced part. And the stable species I have marked in green. So in the reduced part it is the fluoride ion, and in the oxidized part it is lithium ion. Reason for their stability, there are various reasons. This, for instance, is completed its octet and is the smallest anion, and this lithium plus is again completed its octet in the first group, and it can be considered as one of the smallest cation. So there are different other reasons. Anyway, the most stable is, in the case of reduced one it is fluoride, and in the case of oxidized one it is lithium unipositive ion. If fluoride is the most stable one, then its counterpart in the redox couple, that is fluorine, will be the most reactive one. Similarly, if Li plus is the most stable one, then its counterpart lithium metal will be the most reactive species among the reduced forms. And in the oxidized form it is fluorine that is the most reactive species. That means both reactive and stable ones belong to the same redox couple. So if you look, the reactivity or the stability, if you are looking into the reduced species, stability decreases down, and finally when reaches here the stability will be minimum. That means the lithium will be highly reactive. So I am going to mark reactivity. Reactivity is maximum for fluorine. When it comes down, the reactivity decreases, and finally least reactivity will be for Li plus. That means it is the most stable one. You can mark it like this. So reactivity is least for Li plus, reactivity increases, and it will be maximum for F2. If you look into the oxidized species, what is oxidizing power? If you define oxidizing power, it is the ability to take away electrons from others. So fluorine is actually gaining electron, and this electron fluorine gained from these reduced species. So it is helping this species to oxidize. That's why it is called oxidizing power. It takes away electron. Fluorine takes away electron from other reduced species. So it acts as an oxidizing agent. Fluorine acts as an oxidizing agent because it is taking away electron from other species and helping them to oxidize. So fluorine is an oxidizing agent, and the ability to take away electron is called the oxidizing power. That is its power. And which one among this will be having the maximum power to oxidize? Yes, the most reactive one, that is fluorine. So fluorine has got the maximum power to oxidize others, or oxidizing power. With the when the reactivity decreases, oxidizing power also decreases. So the direction of oxidizing power is the direction of reactivity. So the oxidizing power is least for Li+. Why? Because Li+ is the most stable oxidized form. So it will not be able to accept electron from anyone else. Whereas if you go up, that oxidizing power increases, and the most reactive F2 will be having the maximum oxidizing power. Similarly, we have the most stable reduced form, fluoride, and most reactive one, lithium. So you can again give a direction from here to here. Reactivity increases. Reactivity of reduced species increases from fluoride to lithium, which is opposite to the oxidizing power. So the reactivity increases. What is lithium doing by reacting? It gives away electron. It gives away electron so that this species can reduce. So lithium is actually a reducing agent. It helps others to reduce by giving its electron. So the best reducing agent will be the best reactive one. So if this is a reducing agent, its ability to give away electron is called reducing power. Ability to give away electrons is called reducing power. And which species has this power the maximum? It's the most reactive, that is lithium. And as we go up, this reducing power decreases, and fluoride, which is the most stable form, will not give away electrons. So this is the most stable one. So reducing power increases down for this reduced species. So again, in the case of oxidized species, most stable is Li+, and as we move up, its reactivity increases, and they have the oxidizing power, that means to take electrons from others. This power is maximum for fluoride because it is fluorine, because it is the most powerful, or it is the most reactive one. So oxidizing power is maximum for them, and the oxidizing power decreases as we go down, or increases as we move up. On the other case, for the reduced species, fluoride is the stable one, and as we go down, the reactivity increases. What they will do is, in a reaction, they will give away electron. It is called reducing power. It will help reducing others. So the reducing power will be maximum for the one that is highly reactive, that is lithium. Lithium is highly reactive, and hence its reducing power will be the maximum. And as we go up the series, in the case of reduced species, reducing power decreases, or if we go down, reducing power increases. I hope it is clear now. Okay, next, using this is one of the application of electrochemical series. Using electrochemical series, you will be you can identify whether a reaction is feasible or not between two reactants. So before going to that, we will see some of the important details here. Let's consider a reaction. Cu2 plus H2 giving Cu plus 2H plus. So we have two redox couples here that belongs to two half reactions. Let us identify them. One redox couple is Cu2 plus Cu. So we will identify this redox couple or the half cell that belongs to this redox couple from this series. So Cu2 plus and Cu. This is the same half cell that we saw in Daniel's cell. So out of this redox couple, which is the oxidized form is this one. And this oxidized form Cu2 plus is a reactant in this reaction. Now again, let's see the other redox couple. The other redox couple belongs to She, standard hydrogen electrode or hydrogen electrode, H2H plus. If you identify, you can see it here, H plus and H2 is here. So this belongs to the hydrogen electrode. And among the two reactants, which is in the reactant side, it is the reduced species. So reduced species belongs to the reactants. So in a reaction, always if one is an oxidizing agent, the other will be a reducing agent. So oxidized part is the oxidizing agent and reduced part is the reducing agent. So in a reaction, always reaction takes place between an oxidizing agent and a reducing agent. The thing is, if you look into the oxidized part here, so oxidized part, it's between these two half cells, and the oxidized part belongs to the half cell which is having higher E0 value. So it's always like that. For a spontaneous reaction, the oxidized part always belongs to the half cell with higher E0 value. That's what we are going to read. Oxidizing agent belongs to the half reaction with high E0 value for a spontaneous redox reaction. On the other hand, reduced part or reduced state, the reactant in the reduced state belongs to the half cell whose E0 value is low. So we have two half cell in which the oxidized part belongs to the half cell having higher E0 value, and reduced part belongs to the half cell with low E0 value. That means reducing agent belongs to the half reaction with low E0 value. So I hope it's clear now. We have a spontaneous redox reaction, and in this spontaneous redox reaction, always the reactant or one reactant will be in its oxidized form and the other one will be in its reduced form. Oxidized form is called oxidizing agent and the other one is called the reducing agent. And the oxidized form always belongs to the half cell with higher potential, and the reduced part or reducing agent belongs to the half cell with lower potential. So let's see. We will try to evaluate the statement again. So we have the same reaction. I am going to determine the E0 cell of this redox reaction. E0 cell is equal to, we know that, E cathode minus E anode, which is having higher potential here. Copper is having higher potential, so its electrode potential value is 0.34. E cathode minus E anode, which is anode, it is She, its potential value is 0 and the total value is 0.34. A positive potential means the reaction is spontaneous. So positive E0 value suggests that the reaction is spontaneous. Clear? So why it is so? Because we are always, E0 cell is found from cathode, difference between cathode minus anode. So cathode belongs to the oxidized species. So if the value has to be positive, then the oxidized species should come from an half cell with higher potential. This is what we were seeing in the previous slide. So oxidized species must come from a half cell with higher potential, then only the E0 value will be positive, then only the reaction will be spontaneous. So let's see what happened if the reaction is taking place in the other direction. Just we are trying to see what happens if we are mixing these two and imagining that the reaction is taking place. So let's see the opposite, Cu plus 2H plus giving Cu2 plus H2. Actually this is a non-spontaneous reaction. We will see the value of E plus here. So here if you look into the reaction, Cu is actually getting oxidized, so it will be the anode, and H plus is getting reduced from higher oxidation state to 0. That means this will be the cathode. So E0 cell will be equal to cathode, which is cathode She, 0 minus, which is anode, which is copper, and its value is 0.34, which means that E0 cell will be a negative value. So from this value itself, it is very clear that the reaction will be non-spontaneous. Can I conduct this reaction, this non-spontaneous reaction? Yes, of course you can conduct this non-spontaneous reaction by supplying a voltage higher than 0.34 volt. Again, if I want to conduct this reaction, means this is the reverse of this spontaneous reaction, you just supply a voltage higher than 0.34 volt. A voltage higher than 0.3 volt if you are applying, then the reaction will take place. Which type of reaction? Non-spontaneous reaction. Do you remember a device where we used electricity to conduct non-spontaneous reaction? It is, yes, it is electrolytic cell. Now we are discussing about galvanic cell. So in the galvanic cell, if that reaction those reactions must be spontaneous, and that spontaneous reactions must have an E0 value of positive E0 value. And if the reaction must have a positive E0 value, then the oxidized part must belong to a half cell with higher potential, and reduced part of the reactant must belong to a half cell of lower E0 value. So I hope it's clear now. So the question is, predict if the reaction between Fe3 plus and I minus is feasible or not. They have provided E0 value of two half cells. One is Fe3 plus to Fe2 plus, which is 0.77 volt, and the other one is I2 I minus electrode or half cell, and its E0 value is 0.54 volt. So Fe3 to Fe2 plus, Fe3 plus to Fe2 plus, the oxidation number is reducing. So reduction half cell is Fe3 plus to Fe2 plus, and I2 to I minus, that means I minus to I2, that is an increase in the oxidation number from -1 to 0. That means this is the oxidation half cell. So let's see the reaction. Reaction of Fe3 plus to Fe2 plus is Fe3 plus accepting one electron and getting reduced to Fe2 plus. So this is the reduction reaction and is the cathode. Whereas reaction on the electrode is I minus to I2, 2I minus to I2, leaving 2 electron, and it is oxidation, and this reaction belongs to the anode. What is E0 cell? E0 cathode minus E0 anode. Substituting the values of cathode, instead of cathode, it is the value of cathode is given here 0.77, and the value of anode is 0.54. Substituting the values, we will get 0.23 volt. Since E0 cell is positive, we can say that it's a spontaneous reaction between Fe3 plus and I minus, and hence the reaction is feasible. So this is how we have to write for the board exam. Whereas if the same question is coming for the entrance examination, an objective type, if it is an objective type question, then it is, you don't have to do all these steps. It's very easy to assume. Like I have discussed the previous slide, Fe3 plus is the oxidized part and I minus is the reduced part. So oxidized part should have higher E0 value. This is what we discussed in the last slide. So Fe3 plus must have higher E0 value, and look into the values that they have provided. Fe3 plus has a higher value. That means if Fe3 or the oxidized part is having higher value, definitely E0 cell will be positive. So you don't have to do all these steps. Just looking into it, you can verify it whether the reaction is feasible or not. Let's do one more problem to see. So predict if the reaction between Fe3 plus and Br minus is feasible or not. Fe3 plus and Br minus, and the half cells is given. Fe3 plus to Fe2 plus is one reaction, and the other one is Br2 to Br minus. So which is in the oxidized state? Fe3 plus is in the oxidized state. Looking here, you can see this is the oxidizing agent and this is the reducing agent. So what's the condition? Oxidizing agent, the half cell belonging to the oxidizing agent must have higher potential. See, its potential is 0.77 volt, whereas the reducing agent must have lower potential, but here reducing agent is having higher potential. That means the reaction will show a negative voltage and the reaction will not be feasible. Let's work it out. Let's see how it is done. So according to the half cell given, reaction on Fe3 plus is supposed to be reduction, because Fe3 plus is converting to Fe2 and they are asking for the feasibility of this reaction. So Fe3 plus receiving one electron and get reduced to Fe2 plus. On the other hand, the oxidation reaction, Br minus, its oxidation number increases to Br2 when it leaves out electrons. So the oxidation is happening here. That means this is cathode and this is anode. E0 cell is equal to E0 cathode minus E0 anode, that is value of F, that is Fe, that is 0.77 volt, minus value of anode, that is 1.09 volt, which is equal to minus 0.32 volt. Negative value. That means that the reaction is not feasible and is not spontaneous. So as we have seen in the last slide, can you suggest a way to conduct this reaction between Fe3 plus and Br minus? Is it possible to conduct this reaction? It is not possible in a spontaneous way, but you can conduct using an electrolytic cell. So what you have to do is you have to supply a voltage higher than 0.32 volt. Even if you are supplying voltage of 0.32 volt, the reaction won't happen. Whereas if you are supplying a voltage higher than 0.32 volt, a supply of more than 0.32 volt to this cell will make the reaction proceed between Fe3 plus and Br minus. Otherwise, the reaction will take place between Fe2 plus and Br2. Fe2 plus and Br2. Then it is feasible. Then Br2 is the oxidized state and its electrode potential is higher. Then the reaction is feasible. Let's see in the next slide. Predict if the reaction is the same, but here the species has changed. Oxidizing agent and reducing agents has changed. Between Fe2 plus and Br2 is feasible. So you can see that Br2 is the reduced species and Fe2 plus is the reduced species and Br2 is the oxidized species. And according to our slide, it is the oxidized species must have higher E0 value, and here it is having higher C0 value. Then the E0 value will be positive and reaction will be feasible. Again the same step. First you have to write the oxidation reaction, then the reduction reaction, then calculating E0 cell, which gives 0.32, exactly opposite like what we got in the last slide. That means a positive voltage, and the reaction is feasible and is spontaneous. So again, if two reactants are given, one will be oxidizing and the other will be reducing agent. What you have to be careful is pick the right oxidizing agent. If the oxidizing agent is given, he is having higher E0 value, then higher E0 value means E0 cell will be positive and the reaction will be spontaneous. Now next problem. There are two half cells given, reactions on the two half cells, that is permanganate ion in acidic medium reduces by accepting 5 electron. In that process, E0 value is 1.51 volt. So E0 value of this half cell is given. So this is actually accepting electron. That means the reaction is reduction reaction. Whereas SN2 plus tin in its reduced state is getting oxidized to 4 plus oxygen state, leaving out 2 electron. That means this is oxidation and its E0 value is given. So reduction is having higher voltage, that means reaction is feasible. So let's read out the question completely. Write the overall cell reaction and calculate E0 cell and predict whether the reactants or products are favored. So we will write the overall reaction like this, that you just add all the reactants, then you just add all the products. So before doing that, you have to equate number of electrons. Here there is 5 electron and here there is only 2 electron. So if you want to equate, you have to cross multiply. The lowest common factor will be 10, so that means you have to multiply this equation with 2 and you have to multiply this equation with 5. Then both will have 10 electrons each. So if you multiply this with 2, we will get MnO4 minus 16H plus. Then you are multiplying this equation with 5, so it is 5 SN2 plus, giving, multiplied this with 2, then 2 Mn4 plus and 8 H2O plus, you multiply this with 5, then 5 SN4 plus. This is the overall reaction. Now which is the cathode? This is the cathode and its value is 1.51. E0 cell is equal to E0 cathode minus E0 anode. That means 1.15 volt, that belongs to the cathode, minus 0.15 volt, and the voltage is 1.36 volt. Positive value suggests that the reaction is spontaneous and hence products are favored. So this is how you can answer this question. Now again back to electrochemical series. Next point, you can use electrochemical series to compare the stability between the reacting species and products. So always in a reaction, one have to remember that products are stable than reactants. That's why products are formed and they will never react back. In a spontaneous reaction, always products are more stable than the reactants. That's why reactants are reacting and the products are formed. Again, products are stable then. So if you look into these products, you can say that Cu is more stable than H2 and H plus is more stable than Cu2 plus. Let's see. If this is a spontaneous reaction, that means its E0 cell value will be positive. So positive E0 value. Why? Because the one in the oxidation state, one with the oxidized form, that is Cu2 plus, has higher potential than the other half cell. So positive E0 value means Cu is more stable than H2. The reduced form Cu is more stable than the reduced form of on the reactant side, that is H2. So you can say among the two reduced forms, which is stable, Cu is more stable. So this we have already discussed. You can see here, as the E0 value increases, reduced part stability increases, and the most stable part is F minus fluoride ion. So in this case, if here you are comparing between these two half cells, and in that Cu is more stable than H2. So you can use electrochemical series to compare the stability. Now I am comparing She with a half cell that is having low E0 value, here Mg. So among Mg and H2, which is more stable? H2 is more stable because its E0 value is higher than that of Mg. So you can see that from the reaction here, product side is in the H2 is in the product side, so H2 is more stable. H was actually in the solution before the reaction, and when you add Mg into it, Mg replaces H plus in the solution. So Mg will go into the solution and H plus will come out of the solution as hydrogen gas. So those dissolving in an acid, H plus means an acid, that is in a hydrogen half cell, those dissolves will replace hydrogen, which can be seen when hydrogen gas is evolved from the reaction. So Mg being more reactive, can see here Mg is more reactive than H2, will displace H from its solution, H plus from its solution, and Mg will go into the solution. So Mg metal with negative E0 value is more reactive than H2. Comparing between these two, one with higher E0 value will be stable, that is H2. So Mg displaces H plus from the solution, which is liberated as H2 gas. Now a question: zinc dissolves but copper does not in HCl solution. HCl means acid solution. So zinc will dissolve but copper will not. Why? While looking to the table, you can see that zinc electrodes, the reduced part, zinc metal reduced part has lower E0 value. If it has lower E0 value, that means H2 is more stable. So zinc will go into the solution and H will come out of the solution as H2, because zinc is having low E0 value. In the case of copper, copper is having high E0 value. Since copper is having high E0 value, Cu is more stable than H2. That means H plus cannot come out of the solution as H2. It will remain in the solution. So copper will not dissolve, whereas zinc will dissolve. You can see acid solution with H plus ion represents hydrogen electrodes. So this solution means it's an hydrogen electrode. Zinc metal with a negative E0 value is more reactive than H plus, H2. So this is more reactive than H2, that is H2 having 0 volt. So zinc displaces, zinc when it is in contact with H plus, immediately zinc will give away electron to H plus, and zinc will go into the solution and H plus becomes H2 gas. So it is liberated as H2 gas. Now in the case of copper, copper metal with higher E0 value is more stable than H2, and hence will not displace H plus from this. So it remains undissolved in HCl in an acid solution. So H plus remains undissolved in acid solution. Now let us look two electrodes which out of She. Now we have Ag plus to Ag. Can you find out this half cell? Yes, it is this one, Ag plus to Ag, and the next half cell is Mg to Mg2 plus. So it is this half cell which is having high E0 value. Ag half cell is having high E0 value. E0 value is higher for silver than magnesium. So which metal is stable? From this, can you identify the metal which is stable? Yes, Ag is more stable, whereas Mg is reactive. So in the reaction you can see, because of that Mg, so in the solution it was Ag plus. Now with the reaction, Mg will go into the solution and silver will come out, because silver is more stable than Mg. I hope it's clear now. Now next, a question: suggest an oxidizing agent for zinc. Suggest an oxidizing agent for zinc. So for a spontaneous redox reaction, the oxidizing agent for zinc must have higher E0 value. That means any of these oxidizing agents above the half cell can be chosen as an oxidizing agent for zinc. So any of this, which one will you prefer among this? I will prefer F2 because it's the best oxidizing agent. It will easily reduce or easily oxidize zinc. So the oxidizing agent will be the one I will choose is F2. Next question, suggest a reducing agent for I2. Where is I2? I2 is here. I want to reduce it to 2I minus. So I want to suggest a reducing agent. Where is reducing agent in this table? Reducing agent is this. Which one will I choose? In the case of reducing agent, if you come down, if the E0 value decreases, stronger will be the reducing agent. So all those reducing agent below that half cell of I2, that is all this can be used to reduce or used as a reducing agent. So all this can be used. Which one will I choose? Among all these reducing agents, lithium is the powerful reducing agent, so I will use lithium. Now, can copper sulfate solution stored in zinc pot? Can copper sulfate solutions stored in a zinc pot? That's a good question. Copper sulfate means copper is in solution, and I am going to store in a zinc pot means the metal is zinc. Is it possible? Here the oxidizing agent is Cu2 plus and the reducing agent is zinc, and copper is having higher electrode potential. That means zinc will displace copper in the solution, isn't it? So you cannot store because the composition of copper sulfate will change into zinc sulfate. Zinc is more reactive than copper. You can see it from here. Zinc is more reactive because it's below copper, and zinc will displace copper from the copper sulfate solution, and the reaction is the Daniell cell reaction. Copper sulfate plus zinc giving copper plus ZnSO4. Okay, next, copper does not dissolve in HCl but dissolves in nitric acid. We have already seen why copper does not dissolve in HCl but it dissolves in nitrate. Why? If you look into the E0 cell, it's clearly understood. In nitric acid, it has both H plus and nitrate. HNO3 is the nitric acid, and we have H plus as well as nitrate. So it has She electrode as well as nitrate to nitric oxide electrode. Whereas in HCl we have only one electrode, that is H plus. Cl is in its reduced state. So there is only one oxidized form, that is H plus. Whereas in nitric acid, even though it is in its reduced form, it has H plus in it, which will help further reduction. So if you look into the compound, you can see that in the nitric acid you have H plus as well as nitrate, and the E0 value of nitrate is higher than that of copper. So even though copper is more stable than H2, value suggests that copper is more stable than H2, it is less stable than the products of nitrate half cell. So actually it is not H plus that is oxidizing Cu, but it is nitrate. So you can answer it like this: Cu with higher E0 value than She cannot displace H plus from the solution. So it is having higher E0 value, so H plus cannot help Cu to dissolve. But E0 value of copper is lower than that of nitrate. It is lower than that. So Cu goes into the solution and nitrate is removed as NO. So it is because of nitrate, not because of H plus. So generally Cu will not dissolve in acid solution. Cu will not dissolve in acid solution. But in certain cases like nitric acid that has already a nitrate group inside it with higher E0 value can dissolve copper. So if you want to dissolve copper, you can dissolve it in nitric acid but not in HCl. So next is Selfie Questions 5. What you have to do is pause the video, read the questions, answer it, and once you completed your answers, come back resume the video and evaluate your answers. So the question number 1, arrange the following metals in the order in which they displace each other. So there are certain metals given along with their E0 value. So what you have to do is, you should arrange the metals that will displace other metals from the solutions of their salts. So you have E0 value. I hope you remember the electrochemical series, in which as we come down, that means when the E0 value is low, those metals are more reactive. They will displace metals with higher E0 value in the solution. So that means one that will displace all the metals will be the one with lowest E0 value. Which is the lowest E0 value? Magnesium is the lowest E0 value. So if I am putting the order, magnesium is the lowest E0 value, it will displace all other metals because they all have higher E0 value. Which is the next one? Aluminium, because aluminium has the next value, that is minus 1.66. It will displace other metals, zinc, iron and copper. Next is zinc. Zinc is having the next lower value, that is minus 0.76 volt. It will displace iron and copper. And iron with a value of minus 0.44 will displace only copper, because it is the only copper is the only electrode having E0 value higher than Fe. So clear. Question number 2, E0 value of certain half cells are given. Potassium half cell, mercury half cell, magnesium half cell. Arrange these metals in their increasing order of reducing power. So reducing power is for metals. So that's what they have asked for, metals. So reduced part having reducing power and oxidized part having oxidizing power. So reducing power, as we have seen in the previous question, reducing power increases with a decrease in E0 value. That means that lowest, the half cell with lowest E0 value will be having the highest reducing power. They have asked for increasing order. So first one in the list must have highest E0 value. So it's in this list, it is mercury with 0.71 volt will be having the least reducing power. Then the E0 value is minus 2.37 volt for magnesium. So magnesium will be having the next reducing power, and finally the highest metal with the metal with highest reducing power is potassium, that is minus 2.93 volt. Okay, question number 3, for the galvanic cell reaction. Reaction is given here, in which zinc is oxidized and silver is reduced. Which of the electrode is negatively charged? So negatively charged electrode is anode, that we already know. And which is the anode? Anode is the electrode where oxidation reaction takes place, and oxidation is taking place for zinc. So answer for the first one is anode, and it is the zinc electrode. Second question in this main question is the carriers of current in the cell. What are the carriers of current in the cell? Inside the cell it is ions, and through the external circuit it is electrons. Ions inside the cell and as well as in the salt bridge, whereas electron in the external circuit. Represent the cell. Third question, that when you are representing a cell, anode should be always written on the left, salt bridge and then the cathode. So we will see anode, you have to represent it like oxidation reaction is happening in the anode, zinc, vertical line, zinc 2 plus along with their physical state, then double vertical line that represents the salt bridge, then the silver cathode, that is Ag plus giving Ag. Okay.